So this section is covering a couple things. We're going to talk about terms, what they are. We're going to talk about what like terms are. We're going to get to more details of that later, but then we're going to talk about adding and subtracting terms and what those rules are here. So we're going to cut through these 3 pages of notes today. First of all, what is a term? Term is any number, variable, or a product of a number and a variable or multiple variables. So it's any number, variable, or a product of a number and a variable. So if we look at this, here's some examples of what a term is. So 34, -7. X and Y, it's a variable, but they're being multiplied together, so that is a product of a number or a variable. For Z would be considered a term. -XYZ, so a number and multiple variables would be considered a term. We could think of terms raised to a power, so 2x squared, that would be considered a term of positive 2x squared. We can have a fraction, that would be a term. X over 2. 3 over 4. These would all be considered terms. Generally, like I like to think about it, is like terms are separated by the value of the previous term. And what I mean by that they have value is they're either positive or negative. A constant is a term without a variable. So it's just a number by itself. So constants, just like 34 here, -7, are terms. One thing that's going to help you out immensely in math is to be able to see groups of numbers in terms of terms, so to speak. So for these following problems, what I want you to do is put a box around each term in the following problems. So we're going to get into what like terms are and how we combine those later. Right now, visually, I just want you to see the separation. So you can see here these first 2 problems are the same. This one I actually spaced out the different terms, and here is likely how you're going to be seeing them when we're given in problems. So what we want to do for these next few problems is put a box around each term. Essentially what we're doing is we're kind of breaking up what looks like a math expression. So in here we have a 4, a positive 5x, a -2x squared, and a positive 4y. So again, here it's the same thing, but if I am separating the terms, I am grouping them together to show that separation. All right, so I have a 4, positive 5x, a -2x squared, and a positive 4y. Here it visually looks like it's a little bit better. Here we're just showing how they're different. So I guess we could do this one of 2 ways. We're going to put a box around each term, or you can actually write them out so they're actually spaced out. So if I was to look at this one, this is a 3xy. This is a positive 4x. So that plus, even though it looks like it's kind of part of the problem, it's separating the terms with that value. So that plus goes with that 4x. This negative goes with that 3yz. This positive goes with the 5, all right? And then -6x to the 4th. So another way we can think about it, if you don't want to box them, is we can actually separate this. This will be a 7y. This would be a positive 6. This would be a -2. This would be a positive xy. This would be a negative 76. So again, just so we're looking at something that's bunched up so that we can visualize it more separate. 27xyz, -14, positive 2x squared y to the 3rd. All right, what you want to avoid is not including that value that's to the left of the number. Now obviously the very first term, unless it's a negative, is not going to have a plus there. We just assume that it's positive. So here again we have a positive half. We have a positive 8x. Here we have a negative x over 2, and here we have a positive 99. Make sure you're including that. All right, so for the sake of what we are doing, if you're just doing this, I want to avoid that. That's no good, right? So make sure you're including that value while we're doing the separation of terms. All right, so now rules for adding and subtracting integers. So the first thing I want to talk about, and there's really two ways you can display this. So whenever we see two signs that are right next to it and there's no number in between, so like a plus and a minus, a minus, a minus. So example here, 4 plus, then parentheses, a negative 6. We can essentially think of that as one sign, and we can simplify it. So over here, negative 7 minus a negative 12. The two negatives are next to each other without a number, so we can, what I like to call, merge the signs. And they can really be written either way. Like a 4 and a negative 6 can be written as a 4 plus a negative 6, or it can be written as a 4 minus 6, depending on how we look at it. So rule with, and this is kind of like a multiplication rule too, but also with when we're adding and subtracting integers, if you have a plus and a minus next to each other, so when the signs are different, you can replace that one sign with a minus. If the signs are the same, we can replace that one sign with a plus. All right, so for example, 4 minus a negative 5, we can also think of it as 4 plus 5. All right, 4 plus a negative 3, plus and a minus, so it'd be negative 4 minus 3. And again, you can hopefully visualize these as two separate terms, just like we did in the previous section. You don't have to box these, but we're just practicing the merging of signs. Here, in these two examples, there is no double sign, so we can just leave it. So negative 4 and another negative 4. Positive 6, positive 7. So we can just think of it that way. All right? Over here, we just have multiple numbers, but the rule applies even within the terms. So 5 plus 6 minus a negative 3, so we can rewrite that as 5 plus 6 plus 3. 7 minus a negative 4, change that to a positive, plus a negative 2, plus and minus is negative. And again, here, we can think of this as, hey, I have three terms, a 7, positive 4, and a negative 2. Seeing it this way is going to help us later on. So we're just practicing it now. Negative 3 plus a negative, that becomes a negative. Minus a negative becomes a positive. All right, and it's just a way to clean up the problems. All right, finally, the rules with adding or subtracting. Now, we're going to use our calculator quite a bit, but if you ever want to do mental math, this is the rule within how we do this. If the signs of the integers, or the terms, you can think of terms, are the same, you add the numbers and keep the common sign. So here we have a positive 7, positive 3. 7 plus 3 is 10. That answer is going to be positive. Here we have a negative 4 and a negative 2, so the signs are the same. 4 plus 2 is 6, and we keep the common sign. All right, so over here we have two of the same signs, a positive 8 and a positive 5. So we would add that to 13, and it would be positive as our answer. Positive 6, positive 2, and I know this seems like very basic, but I'm trying to get you to see it in terms of terms. So 6 and 2, 8. Negative 6, negative 10. So two terms that have a negative value. So the signs are the same, so we can add that. That's 16, and the common sign is negative. All right, negative 11, negative 9, both have the same sign. So we know that we can add these together. 11 plus 9 is 20, and I keep the common sign. So that's the basic rule with adding if the signs are the same, and that's why I like to kind of merge them first to show that. But again, you could always separate negative 4 plus negative 2 and go backwards, but the rule still works. All right, so now, if the signs and the integers are different, you basically take the difference of the two numbers. So you subtract the bigger number from the smaller number, and then you attach a sign of what appears to be the bigger number. So for example, I have a positive 5 and a negative 9. All right, so my difference between 9 and 5 is 4. 9 is bigger than 5, and that's a negative, so I associate the negative with that. Whereas over here, negative 5, positive, so the signs are different. The difference between 9 and 5 is still 4, but the positive of that bigger number, which is 9, makes this a positive. All right, so we look at these examples. So I have two differences. The difference between 8 and 5 is 3. 8 is bigger than 5, and that's negative, so my answer is negative 3. I have a positive 6, a negative 2. The difference between those two is 4. The 6 is bigger than the 2, and that's positive, so it just remains positive 4. Here we go. We have a negative 6, positive 10. So again, the difference between 6 and 10 is 4. I take 10 minus 6, I think of it that way. And 10 is positive, and that's the bigger of the two, so it's a positive 4 as well. And here I have 11, positive 11, and negative 9. The difference between that is 2. The 11 is bigger, it's positive, so it remains positive 2. All right, so check out these here. So now we have our double signs, and then we impart our rules. So we have a 5, negative, negative, minus a negative 9. So we can change that to 5 plus 9. The signs are the same, positive 5, positive 9. That becomes 14, obviously, and it's positive because the terms are the same. Okay, here we have a negative 5 plus a negative makes that a minus 3. I have two terms that are both negative, so I can add those together. That becomes an 8, and we keep the common sign. Over here, negative 10 minus a negative, which becomes a plus 10. Right? What is the difference between negative 10 and 10? The difference is 0, and obviously they're the same value, so that's just our answer. All right? If I had one other example, negative 10 minus a negative 12, right? So I have a negative 10 plus 12. The difference between 10 and 12, right, would be 2, and 12 is bigger than 10, and that 12 is positive, so that would remain a positive 2.